Hey everyone, I'm not Dan, but in this video we're going to be learning how to use the combined gas law. It's
Been bitter nights are calling, can't find no sleep. Can't you see I'm falling? Oh no.
Welcome back. Before we go any further, be sure to grab yourself a calculator. Got one? Alright, let's go. Alright, so here we go with the combined gas law, which, as the name suggests, is the combination of all of the individual laws put together into one. And it's really quite a handy little thing, because instead of learning all of the individual formulas, you just have to learn this one, and then you modify it accordingly based on whatever the question suggests. Okay, so let me show you what I mean. Let's take a look at this first example here. So it says a balloon at 25 degrees Celsius has a volume of 50.0 milliliters. What temperature is needed to expand the balloon to 70.0 milliliters? Okay, so we've got degrees Celsius, which is temperature, and we have milliliters, which is volume. So only volume and temperature in this particular question. So if this is our formula right here, all I have to do is pick out the V1 over T1 equals V2 over T2. So here we go, V1 over T1 equals V2 over T2. And now all I have to do is just plug everything in. Okay, so volume 1 here is the 50.0. Put that over T1, which is 25 degrees Celsius. But if you recall, we cannot use degrees Celsius in any of these relationships. In order for the relationships to work, temperature must be in Kelvin. So we're going to take this 25 degrees Celsius and add 273 to turn it into Kelvin, which is 298. All right, so volume 2, what is the temperature that's needed to expand the volume to 70.0 milliliters? So there you go, 70.0. And then T2 is what we're looking for. Okay, so in order to solve this, all we're going to do is some cross multiplication. So we do 70 times 298 divided by 50. Okay, so when you multiply that out and then divide by 50 in your calculator, what you end up with is 417.2. Now, before we can say that we are officially done, we have to remember that this value is in Kelvin, but the original temperature is in degrees Celsius, so we can't leave this in Kelvin. Now, if the original temperature was Kelvin, then yeah, we could leave it. But since we started in Celsius, we need to finish in Celsius, so we're just going to subtract 273. And what we get is 144.2 degrees Celsius. And now we got to look at sig figs. So we're going to go back to the numbers given to us in the question. 25 here has 2 sig figs, 50.0 has 3, and 70.0 has 3. Okay, so that means the smallest number of sig figs here is 2. So I'm going to count 1, 2. The next number is a 4, which means we're going to round down. So this becomes 140 degrees Celsius. Okay, so that's how it works with a 2-variable question. But what about the 3-variable question? Let's take a look at the next one. A gas occupies a volume of 0.350 liters at a temperature of 18.0 degrees Celsius and a pressure of 980.0 millimeters mercury. What will be the volume of this gas at standard temperature and pressure? Okay, so the variables given to us in this question are volume, temperature, and pressure. So we're going to come back to our combined gas law, and we're going to use everything but the moles, because moles obviously was not mentioned in this question. So we've got P1 V1 over T1 equals P2 V2 over T2. Like so. And now we're just going to plug and chug as it is. All right, so we got pressure 1, which is right here, the 980 millimeters mercury. Volume 1 is 0.350 liters. Temperature 1 is 18 degrees Celsius, but remember we have to add 273 to that, so what we're going to get is 291 Kelvin. All right, Now on the other side, what are we going to do? It says standard temperature and pressure. Well, fortunately, I have it written up here. Standard temperature and pressure, or sometimes just called STP, is just a real fast way of just saying, okay, here's some standard values. So instead of writing it out every single time, it's just generally understood that this is how it works, okay? So it's either going to be 1 atm, 760 millimeters mercury, or 101.3 kPa, kilopascals, for pressure, and then it'll be 0 degrees Celsius or 273 Kelvin for temperature. So how do we know which pressure unit that we're going to use? Well, the first pressure unit is in millimeters mercury, so that's the one we're going to have here. So pressure 2 is 760. Volume 2 is actually what we are looking for, and then temperature 2 is going to be 273 Kelvin. All right, we now have successfully set up our equation, and now it's just time for math. Now, obviously, there are several different ways you can solve an equation like this. You could multiply these two numbers together and then divide by 291. You round that number and you write it out. And then you can take 760 divided by 273, round that, and then you could solve it algebraically. But what I prefer to do is to actually do this all in one step. It prevents you from needing to round at all in the middle of a calculation because you're not rounding until the very end, and it actually makes your answer much more accurate when you do it like this. Let me explain to you how I like to do this. So again, we are cross multiplying, and if you'll notice, there are two diagonals here. So we've got this diagonal that has all three numbers, and then we have this diagonal right here which has two numbers and the variable. Always start with the diagonal that has all three numbers. So you are simply going to multiply them all out. So we're going to take 980 times 0.350 times 273, and then we're going to hit equals. And so what you should see on your calculator right now is 93,639. Now instead of writing that out and then stopping and then doing the next calculation, we're just going to keep going because we're going to recognize that we're actually going to be dividing by both of these numbers. Now I could multiply them together first, but why should I do another step, right? I'm just going to divide by both of them anyway. So I'm going to take the 93,639, going to divide by 291 equals, and then divide by 760 equals. And what you see on your calculator is that volume 2 is 0.42339, blah, 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 blah. Lots of numbers here. Now that we have this, it is time to officially round. Okay, so go back to our original numbers. Each of these three numbers has 3 sig figs, so that's how many I can have in the question here. So 1, 2, 3. I'm going to stop. The next number is a 3, which means we round down. So that is 0.423. This is volume. Now volume started out as liters, so that means volume here is also liters. And we have now correctly calculated this particular question. Okay, so what I'm going to do here is I'm going to scroll down. Here are 2 more practice problems for you to do. So I'm going to tell you to pause here real quick. You're going to work them out, and then you'll hit start again on the video, and you'll check your answers, and you'll be able to see how you do. All right, so get ready to pause this video in 1, 2, 3, pause. All right, here are the answers. Check them out, and if you have any questions, please feel free to ask. Thanks a lot, guys.
As always, thank you so much for taking the time to watch. If you have any further questions, please be sure to comment below. And if you haven't done so yet, why don't you go ahead and like the video and subscribe while you're at it. Well, that's it for now. Remember, I'm not Dan, and neither are you. Check you later.